Hello everyone. Hello everyone. Welcome to InfoStream YouTube channel. So in this video, let's discuss how to solve the Hasse diagram problem. So first, let's discuss what is Hasse diagram. So Hasse diagram is the pictorial representation of poset. So what is this poset? If this is the relation set which has been given, this must satisfy the three conditions, that is reflexive, symmetric and transitive. So if it satisfies all the three conditions, then it will be called as a poset. So when you will be appearing with the Hasse diagram problem in examination, so it will be a poset only. They will give the question related to poset itself, no need to recheck it. So let's solve the problem directly. So to solve the problem related to Hasse diagram, we will be following 4 steps. The first one is to draw the diagraph. So how to draw the diagram means just to use the relation sets which has been given here. So step number 1. If you see here, what are the elements in my array? 1, 2 and 3. So I will be taking 1, 2 and 3. You can call it as set also, array also. Now I took 1, 2 and 3. Here there is a combination of 1, 2 and 3. That is the relations. So using those I must draw the diagraph. So 1 I will be using, 2 I will write here and 3 I will write here. So you can write 3 here also, anywhere you can write. So first let's draw the diagram. So 1 comma 1 means self loop. Next 1 comma 2, from 1 it is going to 2. 2 comma 2 means we will be giving the self loop. 3 comma 3 means also self loop. 1 comma 3, so from 1 there is a connection to 3. Next 2 comma 3, from 2 there is a connection to 3. So now at the first step you designed the diagram. Now let's move to the second one. So what second step tells? Remove the reflexive and the transitive edges in the diagraph. So the second step is, first let's remove the reflexive. So reflexive means wherever there will be a similar one. Here 1 comma 1, 2 comma 2, 3 comma 3. So this will be called as the reflexive. So the self loop will be removed from the diagram. So the self loop will be removed from the diagram. Next, we must also remove the transitive edge. So transitive means if there is a relation from A to B and also a relation from B to C. A to B, B to C, that is the 3 different elements. And if there is another one relation where there is direct relation from A to C. A to B, from B to C there is a relation. Now if there is a direct relation from A to C, then you can call it as a transitive. So that edge we must remove. So if you see here 1 comma 2, so I will be considering 1 as A and 2 as B. Next, whether there is 2 here, 2 comma 3. So 2 will be same, B and C will be 3. A value is 1, B value is 2, C value is 3. Now, if there is a relation from A to C, that is 1 comma 3, then there is a transitive edge. So here 1 comma 3 is there. So you can conclude that there is a transitive edge. So I must remove that one. So from 1 to 3 there is a transitive edge. I must remove that one. Now in the second step, whatever will be left after removing the reflexive and the transitive edge, we will write it. So 1 is left. From 1 there is a edge to 2. Next, from 2 there is a edge to 3. From 2 to 3 there is a edge. Now, after the removal of the transitive and the reflexive edge, this much is left. Now let's move to the third one. So the third step is draw the diagraph where all the edges point upwards. So in the step number 3, we must draw the diagraph so that all the arrows which are pointing downwards, they must be showing upwards. So how to decide whether I must take 1 in the downside, that is as a base, or 2 as base, or 3 as base, means whichever the element or the vertices or nodes which is not having any incoming edge coming towards it, it will be considered for the basement or the base one. So if you see here, 2 is having a edge incoming from 1, 3 is having a edge incoming from 2. So 1 is not having any edge, that is incoming edge towards it. So 1 will be written at the base. Now from 1 there is a connection to 2. From 1 there is a connection to 2. Next from 2 there is a edge or a connection to 3. Now whether we must write this like only? No, you can write like this also. 1 to 2, from 2 to 3. So in any shape you can write, but one thing you must keep in mind, the arrows must be upward. If it is little tilted also, nothing will happen, but it must show upwards itself. So now the last step, step number 4. So in step number 4, remove the directions. Here the edges are there, no, you must remove the direction of those edges and replace the circles with the dot. So here 3, there is a circle, no, we must remove it and replace it with the dots. So here as you wrote the diagram, that like only you must represent here. This is for 3, next this is for 2, this is for 1. Now we remove the circle and replace it using the dots. And another thing is remove the directions also. So there is a edge between 2 and 3, but we must remove the edge direction. So here also from 1 to 2 there is a edge, but we must remove the direction of that edge. So if you see here, this is the final assay diagram. So what we did here, first step we draw the diagraph using the relations set which has been given in the problem itself. After writing the diagraph, we remove the reflexive. Reflexive means self loop. 1, 1, 2, 2, 3, 3, like that. Next we remove the transitive edges. So what is transitive edges? From A to B there is a connection or a relation. From B to C there is a relation. Means if there is a relation add from A to C directly, then we must remove that one. So we remove the reflexive and transitive in the second step. So in the third step what we did, we redraw the diagraph. That is, we redraw the diagraph in such a way that all the edges were showing upside. All the edges direction must be showing upside. How? We decided the basement first. That is the base element or the node. How? Which was the element or the node which was not having the incoming edge, it was considered for the base one. Here 1 was not having any incoming edge, so 1 was decided for the base and then we constructed the diagram. So in the last step, we replaced the circles using the dots and we not gave the direction for the edge which has been connected between two vertices or the nodes. So this is the simple way how to solve the assay diagram. So the more video link will be given in description, because the more problems you solve related to this topic, you will be perfect in that concept. So if you have any doubt regarding this topic, please do comment below, I will clarify it. And if you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.